Hello, everybody, and good Friday morning and happy Earth Day. My name is Tim. I work at the Urban Ecology Center, and welcome to the Backyard Naturalist. I have a lot of personal connections to this week's topic, the moon, which is the name we generally give to our moon, the Earth's moon, which distinguishes it from the moons of Saturn or Jupiter or Mephisor. And I think it's kind of cool that it's so important that we just call it the moon. Um, which then makes me wonder, why don't we call the sun like the star, right? That's a pretty important star. Why isn't it the star? Like we have the moon or our planet Earth. We don't call it the planet. So we have Earth, sun, and the moon. That's how important it is. It's just like the moon. Um, so I love to look at it and to contemplate, to admire its beauty. If I'm looking outside, if I'm outside just under the stars or hanging out on a beach or in a boat, wherever I am, the moon just really draws my attention. And I particularly remember the first time that I left home for a significant period of time and was like anticipating the kind of homesickness that I would start to get. Uh, and there was something very comforting. I remember, I think it was the drive to the airport, just looking up and seeing the moon. And uh, there was just something kind of calming and comforting, realizing that whatever faraway land I was venturing to, I would still be connected to my own backyard in Milwaukee through the moon. So I could look at the same moon as my family and friends back here in Milwaukee. And I just really love that thought, that connection. So I hope you enjoy this brief journey with me today to that celestial connector, the moon, in episode 30 of season 3 of the Backyard Naturalist. Hi, Moon. But first, as always, a huge thank you to all of the UEC members and especially the Backyard Naturalist subscribers for their support, which keeps this program running. Today is Earth Day. And after we celebrate today, the Urban Ecology Center is ready to get to work with an Earth Week, which that kicks off tomorrow, Saturday, April 23rd through the following Saturday, April 30th. And there's projects ranging from river cleanups and neighborhood trash pickups and to community garden preps, to invasive plant pull-a-thons, to bird walks. And for more details on how you can get involved, you can visit the Urban Ecology Center website. And one of the most exciting UEC Earth Week events is going to happen right here for Backyard Naturalists next Friday, April 29th, as we will have some very special guest speakers from a very special neighborhood partner, Nearby Nature Milwaukee. So we'll have 3 people from this wonderful organization, including our very own Karen Samuelson. We'll speak primarily about their environmental justice and equity initiative, which focuses on Milwaukee's northwest side, especially along the Lincoln Creek watershed. And so they use conservation projects such as native plantings and other efforts to improve and draw attention to places like the long neglected Lincoln Creek Greenway. So it's just fantastic that this area is receiving some love and attention. And I'm just so happy that Nearby Nature exists and is gaining steam. And I encourage you to check them out, to volunteer with them, to support them. And Nearby Nature Milwaukee also has some Earth Day events coming up tomorrow, Saturday at Lincoln Creek, for a cleanup from 10 to noon. And they're also partnering with the UEC and Sierra Club Waters Group for an outdoor expo and green resource fair at Washington Park from 9 a.m. to 1 p.m. So lots of great activities coming up over the coming week. And we're also just a few weeks away from the Brew City Birding Festival. I've mentioned a few of the events already, from the Green Birding Challenge to the Horicon Marsh Field trip. If you visit the website, you'll find some fantastic events happening. There's a field trip to the Magma Nature Preserve in Ozaukee County and to Manches County Park in Waukesha County, as well as some great programs. There's one entitled Good Fowl Hunting, about how a duck hunter and a birder relate, probably more than they unrelate, if that's a word. And then there's a virtual bird workshop where we'll all be able to channel our inner Bob Ross and create our own happy birds in the comfort of our homes. So for more information on the festival, visit the Urban Ecology Center website or contact anyone on the research team at the center. From the human phenology side of things, I was remiss to mention last week that this year is quite special in that we often talk about celestial conjunctions, but there was a human religious conjunction in that Passover, Easter, and Ramadan were all happening at the same time. So that's a fairly rare conjunction of major holidays representing the three largest monotheistic religions on earth, Judaism, Christianity, and Islam. So, and then we do also have a celestial conjunction coming up. So I encourage you, if you like to get up early in the morning, to look at the stars next weekend, April 30th to May 1st, because Venus and Jupiter are going to get so close to each other that they're going to look as if they are one object. So to do this, you're going to have to get up pretty early, about an hour before dawn as they rise. And if you have a clear view to the southeast, as dawn approaches, you'll start to see a very bright reddish Jupiter rising right next to the kind of yellowish white appearance of Venus. And to the naked eye, the two will look almost as one. And then if you have binoculars or a telescope, then you should be able to tell them apart. And just a few days before that, on April 27th, they won't be as close, but the moon will be crashing the party in those same early morning hours. And you'll be able to see Mars and Saturn. So just a big planetary lunar party coming up next weekend in the hours before dawn. And April 30th marks a partial solar eclipse, but we're not going to be able to see that here in the Northern Hemisphere, or anybody viewing from the southern parts of the Southern Hemisphere. So anybody tuning in from Antarctica or Southern South America will be able to see it. And early this morning was the peak for the Lyrid meteor shower, but then on May 4th and May 5th, we're going to see the peak of the Eta meteor showers, which will be one of the best of the year. So lots to see. And then keeping on this theme, a lot has been happening in the world of space exploration, which it sets an interesting backdrop as we talk about the moon and puts a new perspective on things, because recently we just had it's a first. We had the first time that 3 private citizens, non-astronauts, you could call them tourists, from the United States, Canada, and Israel, visited the International Space Station aboard the private SpaceX's Crew Dragon. So this is kind of essentially that next step in space tourism. They're there now, and they'll return to the Earth in that same spacecraft. They're undocking tomorrow night and then splashing down in the ocean near Florida on Sunday. So space tourism is really gaining steam. It moved from, we started to hear of these visits to space, which has been happening quite a lot lately, and now we've taken that next step of bringing these non-astronaut private citizens to spend time at the ISS, the International Space Station. So in addition to its role in science and space exploration and astronomy, the ISS is starting to function as a hotel. And in related news, 4 more actual astronauts are going to take that same rocket that's bringing these tourists back. They're going to take that same rocket back to the ISS. So they're replacing the quartet of astronauts that went up in November of last year. And one of the new team members, Jessica Watkins, will become the first Black woman to become a full crew member aboard the station. And it's kind of interesting to note that the launch date for this crew of actual astronauts is being delayed because they have to wait for the tourists to come home because their flight was delayed by weather. So it's just this bizarre new marriage of astronauts and tourists. So this is the future now, this amazing, bizarre marriage where tourists and astronauts are kind of working around each other's schedule, and this interplay of public and private space exploration just might come into play as we transition into the moon stories, because that's probably the next step in this space tourism journey. So a lot has been happening in terms of space exploration, but it has been a long time since NASA has focused on our nearest neighbor. There have been a couple of fits and starts, And our story begins back in the 4th century before the Common Era, when apparently pupils and irises hadn't yet come on the scene as adaptations of the human eye. But this depiction of the Greek philosopher Aristotle, he believed in the geocentric model of the heavens that incorrectly put the Earth at the center, not only of our solar system, but of the entire universe. Then it took 2,000 years before Galileo put forth the heliocentric model, where it correctly put the sun at the center of our solar system. But it was the study of the moon that played a really big role in putting forth this new correct model. Plus, Galileo had access to telescopes that Aristotle didn't, and by now people had evolved irises and pupils, which gave him an advantage. But apparently smiling won't be around for another couple hundred years at least. But if we go back to Aristotle briefly, he and others, when they looked at the moon without, again, the aid of telescopes, they noticed that there were dark areas and light areas. And so at the time, it made sense to think of that as the moon having oceans and continents. So he called the dark areas Maria, or seas, thinking that they were oceans, thinking that they were water. And then he called the lighter areas terrae, or land, thinking that those were the continents or the areas of highland that surrounded by these seas. So today, and I hope this isn't too much of a spoiler, but we know, or that there's no surface water on the moon. And so both the light and the dark areas represent solid ground, but they were named as if they were oceans, and those names are still around today, which is why the first Apollo lunar landing mission, Apollo 11, landed in the Mare Tranquillitatis, or the Sea of Tranquility. And then from 1969 to 1972, 14 humans, all from the United States, set foot on the moon. And in addition to doing things like driving fast cars and golfing, they also brought back 842 pounds of moon rock and dust to study back here on Earth, which really helped us reach our modern understanding of how the moon works. So if we look at the moon today, we see a pretty different picture than the early astronomers. After the invention and refinement of telescopes and then all these lunar missions, we know today that about 15% of the moon surface is made up of those darker colored Maria, and 85% is made up of the lighter colored Terra. So the Maria are areas that are low in altitude and are relatively flat, and they're much smoother. They have much less evidence of meteorite impact, while the lighter Terra areas are the higher mountainous areas, and they're just littered in these craters. So why is that? This is where we need to go back even farther in time. So now 4 billion years ago, and the Earth and the moon were only about 500 million years old. There was a period of about 1 billion years where both the Earth and the moon were just constantly pelted in intense meteorite action. Asteroids, meteorites, they were just constantly bombarded in this young solar system. And so looking at these artist perceptions, it is certain that both the Earth and the moon looked very different 4 billion years ago. In addition to all these crater impacts, they were both much hotter as their molten rocks were kind of getting settled. And then there was this just intense meteorite activity. And now today, the two planets look very different from each other and from what they looked like back then. And there's two main reasons. So the intensity of those large objects hitting both objects is much, much, much lower, much less frequent, thankfully. And then second, most of the meteors that are earthbound, they burn up in the upper atmosphere. It kind of acts like a shield, like a force field. And this is the process, of course, that produces the wonderful shooting star displays for us. And then the third big thing is that the Earth today is still very active geologically and meteorologically. So wind and water are just constantly smoothing out and changing the surface. So most of the evidence, almost all of the evidence of those early craters has been erased in the Earth's surface. While on the moon, which is tectonically almost completely inactive, there's nothing there to erase those millions of years of impact craters. So the evidence is still very much there. And seismometers on the moon detect virtually no seismic activity, virtually no tectonic activity, no shifting of plates as there is here on Earth. There are no moonquakes, and magnetometers on the moon detect no substantial magnetic field, which means there's likely not that active molten iron core that we have on Earth. So a very, very active Earth and an extremely inactive moon. In fact, modern pictures of the moon can still find very, very well preserved evidence of those earlier human missions 40 years ago, from the buggy tracks to pieces of machinery to just, it's amazing that footpaths from a single person appear to be permanently etched into the landscape. Here on Earth, you have paths like that from like wildebeest or elephants, but that's, multiple times of treading over the same path. And here is one human making a path 40 years ago that still is easy to see with our satellite photos. And some recent photos found the wreckage and impact crater of the Lunar Orbiter 2 on the dark side of the moon looked like it had just hit, even though it was 40 years ago. And they found the golf ball that Alan Shepard famously hit several decades ago on the moon. So pretty much there's just very, 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 very little activity on the moon. But at one point, the moon was very active geologically. And we know that because we see the evidence of these older lava flows and lava tubes and things called rills, which are these channel-like depressions you see on the photo on the right that were formed from molten lava. There's no soil on the moon because, as we've learned in some of our previous episodes, soil requires organic matter. And as far as we know, there is no organic matter on the moon. So you could call it dirt, but technically the moon is covered in what's called regolith, which is a very fine particulate dust, something that any mission to the moon has to deal with. And it's called moon dust, but also called regolith. And that's mixed with bits of volcanic glass from the previous volcanic activity and then some larger rocks. So then if we go back to the lunar seas, the Marea, that is primarily, those darker areas of the moon are primarily basalt or igneous rock, just like here on Earth, from these ancient lava flows that erupted and covered the surface of these lower areas. So that's one of the reasons that you don't see the evidence of these craters from 4 billion years ago in these seas, because the lava has kind of smoothed it over. So very similar what happens to volcanoes on Earth. And then this represents younger and darker rocks from cooled lava. But then the bright parts of the moon, the terrae, are covered in the original rocks, the oldest rocks from when the moon first formed. They're primarily anorthosite, which are highly reflective, and that's a good thing, highly reflective and light colored, because that's what gives us that beautiful moonshine. Moonshine, I guess moonshine is, there's a couple things, moonshine, but moonlight maybe is a better way to put it. It gives us our moonlight, the reflected light from the sun. And, it's so bright that on a dark, full moonlight, you can read by the light of the moon. And that's made possible by this really old, reflective, brighter anorthosite rock that, again, covered the young moon's entire surface before that intense period of pummeling. But that pummeling also produced what we call lunar breccias, which are aggregates of the debris that formed during that intense period of meteorite activity. So meteorites not only pummel the planet, but they also heat and recool rock, and it's kind of morphed into those rocks. So this is all located in those highlands. They weren't smoothed over by the lava like the seas were, the mare were. And so they preserved those earliest processes on the moon, which then brings up the question, how did the moon form? What were the processes that created the moon? So before the lunar landings and before all this study, there were 3 major hypotheses. The first one was that we are essentially a double planet system. This is the double planet hypothesis. So as the solar system accreted and the planet started to form, we just had the material here formed these two objects at the same time, about 4.5 billion years ago. So you have this kind of double object, double planetary system. But there's two major reasons why this hypothesis doesn't hold well. So first is that the composition of the Earth and the Moon are very similar, but they're different enough so that they don't suggest that they were formed at the same time from the same materials. And the age of the two bodies are different, not by a lot. We're talking maybe 13 million years different, but that's different enough than one would expect them to be if they were formed at the same time from the same materials. So this hypothesis doesn't really hold today. The second major hypothesis is called the capture hypothesis. And in this scenario, the moon was just kind of traveling through the solar system on a big road trip, and then it passed by the Earth, and our gravitational pull said, hey, come over here, hang out with us. And it just kind of pulled that object into an orbit. But based on our knowledge of astrophysics, this scenario just doesn't seem possible at all. Extremely unlikely. Makes a good story, but an extremely unlikely story. And the third major hypothesis is also kind of a fun story. It's called the fission hypothesis. And in this scenario, the early Earth was spinning really, really fast. And so just it's so fast that a big blob of molten Earth just kind of like was wee and kind of got shot out into space, but then captured in orbit. So fun to think about, but also extremely unlikely based on what we know about astrophysics and modeling. There is, however, a scenario that has held up extremely well to today. And it's the most likely scenario of how the Earth formed. And that is that the moon was created when a very large object, about the size of Mars, violently collided with Earth and then just kind of became absorbed into the Earth, just kind of swallowed it up. So it's still part of our planet today. So that material was different, but then what it did is it shot off these huge chunks of magma from the Earth into space. Kind of like when a water droplet hits a puddle or a lake, you get the water itself is absorbed into the lake, but then you get that little blip of water that kind of goes up into the air. So probably something similar. The foreign object got swallowed up, but then parts of the Earth were pushed into space. Molten parts of the Earth were pushed into space, and then they eventually formed the moon. So the process kind of vaporized or cooked that Earth rock that became the moon, which then it helps explain why, first of all, moon rocks are very low in water and volatile materials. So it's essentially what would happen if you took a chunk of the Earth and scorched these materials out of it. The moon can be thought of as like a charred Earth, just like charcoal is charred wood. You take wood, you lose its volatile compounds, its water, and you make that charcoal. It's a very similar process to what we think what the moon is parts of the Earth that were kind of charred and baked and then aggregated into its own orbit. So the theory still holds up today. It's kind of cool to think of, and that also explains why the Earth and the moon has that slight age difference, because but they're very similar. So it essentially was parts of the Earth that were kind of reformed and put into space. And an interesting result of this process is that the very early moon that shot off the Earth likely consisted of a solid inner core surrounded by an ocean of magma. That so the opposite of the Earth and the opposite of what the moon was for a while. And so you have this, eventually that outer magma solidified, and then you had the inner part of the moon as the molten part. And then eventually, so it kind of starts to look like this with less features. So for a while, looking at the moon, you just kind of see this featureless sphere. But then eventually that internal magma started to seep out. And that's what, in addition to all of the craters and the mountains that were created by that pummeling, that started to create the features of the moon. And then that lava that kind of seeped out from the inner part is what caused the lighter and darker colors. So you kind of have this evolution of what the moon would look like from the Earth. At the beginning, it's much larger. It was closer. The moon is still on a journey, getting farther and farther from the Earth and slowing down in its revolution. But you could imagine seeing that early moon would be pretty darn cool as this kind of glowing, large sphere, very scary. And then you kind of see that evolution of what the moon likely looked like from the Earth.
Tim?
Yeah.
We have a quick question. Is there magma in the moon today?
There is almost, they think there's virtually no activity in the moon today. So while it's probably likely to say that there's not any, it's considered kind of a dead planet. There's nothing going on. There's no lava coming out. There's nothing. The inner core is probably just as dead as, it's a terrible word to use, but it's just not as active. So it's just kind of like considered a cold lump. But I think as we hopefully start to return and study the moon, I think we're going to probably, I'm sure, be surprised with some intricacies that we didn't think of, but to our best knowledge, it's not active at all. I know we have some astronomers on here today that can probably set the record straight in some ways, but from what I understand, it's pretty lifeless in more ways than one. So, all right. Another really kind of cool offshoot of the moon formation is that huge droplet of Earth, when it shot into the sky, we don't think it was spinning. It was just kind of blobbed out there. So without any appreciable spin or rotation on its own axis, which is what most of the planets and moons do, it's kind of just dragged along by the gravitational pull, similar to when you attach a ball and a string and then swing it around your body, like in this hammer throw, so that the ball isn't rotating, it's fixed. And the same side of that ball is always facing the thrower in this case. So as she's rotating, the ball is always facing her. It's not spinning on its axis. So the same side of the moon is always facing the Earth because of this kind of anomaly, which is why the full moon looks the same whenever you see it. We see that same little rabbit because that's the only side we ever see. And that's why there's the dark side of the moon. It's not the dark side of the moon because it never receives sunlight. It's the dark side of the moon because we just can't see it unless we go to the moon with an orbiter and a camera. So the moon doesn't rotate, but because it orbits the Earth, the position of the moon relative to the sun and the Earth, it is always changing. And even though we always see the same side of the moon, the orbit of the moon around the Earth is much slower than the rotation of the Earth. So an Earth rotation takes about 24 hours, but the revolution of the moon around the Earth takes about 29.5 days. If these two processes were at exactly the same speed, if the moon revolved around the Earth in a 24-hour cycle, not only would we see one side of the Earth, but only one side of the moon, only one side of the Earth would ever see the moon. If you're on the other side of the Earth, you'd never see the moon. That's kind of a neat thought to think about, but they're offset. And so that's why the moon appears to go through these phases. So when we see the full moon, the moon and the sun are on opposite sides of the Earth, which is why the full moon rises as the sun sets. So then the moon that we see is fully bathed in the sun's light, which is why it's called a full moon. But then when there's a new moon, the moon's there, it just kind of disappears from our perspective because we can't see it because the sun's rays are reflected away from the Earth. So it's hard to see because we're facing the side of the moon that's essentially in its own shadow. But one of my favorite perspectives of the moon is when you have Earth shine, which is essentially light that's reflected off the Earth that gives light to the dark side of the moon, just as the moon provides light to our night times, we provide light to the moon's night times. So if you lived on the moon, you'd probably call it Earth light, and maybe it would be so bright during certain times that you could read a book on the moon from the Earth light, Earth shine. And then as the moon is cycling from the new moon towards a full moon, from our perspective, the amount of lit moon is growing bigger. We call that a waxing moon. And as the amount of lit moon shrinks from our perspective, we call it a waning moon. When the moon is more than 50% lit, it's called a gibbous moon. And when the moon is less than 50% lit, it's called a crescent moon. So you can have a waxing crescent, a waxing gibbous, a waning gibbous, a waning crescent. At 50% light, it's called a quarter moon. And then I love how they just kind of throw in the terms young moon and old moon, just for fun. The orbit of the moon around the Earth is not circular. It's elliptical. And so the orbit continues to slow in addition to the moon getting farther. But when the moon is closest to the Earth, we call it at perigee. And when you get a full moon at perigee, at its closest point, it's called a supermoon. And that's been loosely associated with increased tectonic activities like earthquakes and floods. And then, depending on who you talk to, it also affects human behavior. That's up for debate, but you get arguments on both sides. And then knowing what we've all learned about nature, it doesn't surprise me at all that our bodies are affected by this in more ways than we probably understand. At the farthest point of orbit, the moon is called at apogee. And so, in a given day, we're not going to probably tell the difference between the sizes. It's like looking at a Cooper's hawk or a sharp-shinned hawk by itself. It's really hard to tell the size. But then when you put the two together, you really do kind of see that they are pretty different from our perspective in terms of size. So, again, you really don't notice it unless you look at this. And we're not going to get into eclipses here, but the distance from the moon to the Earth will also affect the likelihood and the extent of eclipses. So in a solar eclipse, the Earth is completely blocking sunlight from reaching a small portion of the Earth. And then in a lunar eclipse, the Earth is blocking sunlight from reaching the moon. And if you want to sound smart at a party, just mention that anytime you have a solar eclipse, which happens during a full moon, you will also have a lunar eclipse during that cycle when it hits the new moon. So they're paired together. And as we wrap up, I do need to at least mention one of the very coolest effects of having a moon revolving around a planet that affects all of us, that affects our backyards, our seas, and that's the gravitational forces of the moon actually pulling on both the planet and the water on our planet. Which in effect causes the water to rise, but you could also kind of think of it as the Earth sinking. It's a matter of perspective. Either way, the water table is moving up relative to the ground, and you have a cycle that happens roughly every 6 hours of high and low tides, based on whether you're, closest to the moon or at the farthest point away from the moon. And there are major implications of these forces, from life, tidal pool ecology, to humans using tidal forces as a renewable source of energy. There are lots of other things that the moon does for us. They stabilize our wobble. So if you think of a top spinning on a table, and you start to see the top of the top kind of wobble in a circular motion, and eventually that wobble gets bigger, and then the top kind of falls over. But our moon functions to stabilize our wobble. So we do have a wobble, but the moon helps stabilize that. So it keeps us in that relatively fixed north-south orientation, about 23 degrees off the axis of our orbit. But that wobble does mean that in 23,000 years, the North Pole, Polaris, is not going to be due north anymore. Vega will be. So that little wobble kind of affects our astronomy, but again, it's over tens of thousands of years, so we don't really notice it in our lifetime. But it's something that the earliest astronomies did have a different set of or perspective to work with. So I began the talk with the reflections on how the moon connects us spatially on Earth. And then the other side of that that is fun for me to think about is that it connects me with not only people that are many thousands of miles away, but people that are many thousands of years old, gone. They had that lived here many thousands of years ago. So it it connects us, humanity, with our past. So just as the earliest humans and the proto-humans and other species sat around campfires telling stories, just like we can today, contemplating the world, these same early humans most assuredly paid attention to the moon, wondering what it meant that this object would appear and disappear in these regular cycles. And so that fascination has continued over the centuries as the moon continues to be the center of our stories. And you think of how this object helped early humans, in addition to other animals, see better at night. So we and they alter their behavior depending on whether the moon is out or not. That'll affect, whether you're going to hunt, how you're going to behave as a prey, and whether it's full or not. So these cycles are very real, affecting humans less so with our artificial light, but a lot of animals, without much of the light pollution, that's a big deal, and very likely was huge to early human behavior. So the moon is at the center of our stories. It's at the center of our research, of our exploration. Pretty soon we'll likely have to strengthen conventions about who owns the moon, who can exploit it, and that time is likely coming soon, when we'll be able to sit on the moon and look down on the Earth for a different sort of contemplation and reflection. But for now, I'm glad the moon is there, as it always has been for us. And I love it that it connects my backyard with the rest of the world and with history. So thank you for joining me. Look forward to seeing you again next week. I will stop sharing my screen.